All right, in this video, I'm going to show you how to write an equation of a circle in standard form given different information. So now I have 8 examples. Yes, 8, because I want to show you an example of each type of problem that you may see when you're practicing or when you're completing a test. And so we'll get started in 11 seconds. Standard form of a circle is x minus h squared plus y minus k squared equals r squared. H and k right here, that will be the center of the circle, and r is the radius. Now the first two problems that we're going to write equations for, we're given the center and the radius. So the only thing we're going to do is just take our information and plug it in. So the first thing I'm going to do is just label everything. The center is HK, all right? And then the radius is R. So I'm just going to take this information and plug it in. That would be X minus H is 5 squared plus Y minus K. K is 3 squared equals R squared. R is 2 and 2 squared is 4. So that would be equals 4. All right, and so we've written this equation in standard form for this circle given this information. The second one, again, I'm just going to label it HK. A little different because we have that minus here. So that would be X. We have minus 1, and we have a minus or a negative in our formula, and we have a minus and negative here. So when you subtract a negative, what do you get? You get a positive. So minus a negative or a double negative, that's going to give you a positive. So that would be positive 1 squared plus y minus 7 squared is equal to 14 squared. That is 196. So that is equal to 196. And so we've written this equation in standard form using the given information here. So let's take a look at these examples here. We're given the center and we're given the diameter for this one. So now remember, the diameter goes across the circle, so it goes from one edge to the next. And the radius is from the center to the edge. And so the radius is half of the diameter. So if we're given the diameter, we just take half of it to get the radius. And so half of 32 is 16. So our radius is 16. And labeling our center, HK, then just plug it in. X minus 0 squared plus y minus 9 squared is equal to 16 squared. I'm going to simplify this a little more. If one of our values is 0, we don't need it. So to put it as simply as we can, we just write this as x squared. We don't need that 0. Plus y minus 9 squared is equal to 16 squared, which is 256. So that is this equation in standard form. So you don't necessarily have to have both parentheses if one of your values is 0. All right. The next one here, again, I'm going to label HK. Our radius is has a square root. And so remember, when we do our equation in standard form, the radius is squared, right? So 158 under the square root sign would have to be squared. So now remember, if you have a square root and you raise it to the second power, because this is really to the 1/2 power, so it's going to actually eliminate that square root sign. So my radius squared would just be 158 when I plug it in. All right, so let me show you. X minus 15 squared plus y, since that's a minus 16, that would be plus 6, not 16. 6 squared is equal to, so our radius squared, right? If we raise this square root of 158 to the second power, it's going to eliminate that radical. So it would just be 158 because we raised it to the second power. All right. And that is our equation in standard form. All right, so let's take a look at these two examples here. Once again, we're given the center, but we're given the circumference and the area in each of these problems. So I'm going to label this again HK. So now for my circumference, I'm given that it is 6 pi. So remember, the formula for circumference of a circle is 2 pi r, or pi times d. So if the circumference is pi times d, we already have a pi here, so that would mean that that 6 is d, or our diameter. So if our diameter is 6, our radius would be 3. And so we would just plug it in. All right, x, that double negative, is plus 1 squared plus y minus 4 squared. My radius is 3, so 3 squared is 9. All right, what about the area? So now the formula for area is pi r squared. And so my radius here will actually be 4 because you have the radius squared here. So if you take the square root of it, the inverse would be 4. But just to show you the rationale here, the area is 16 pi. If I plug in 16 pi for the area into that formula, so 16 pi is equal to pi r squared. Hopefully I'm not confusing you. I'm just going to show you how I'm getting 4. So if I solve that for r, right, I want to divide both sides by pi because I'm trying to isolate the r, or the radius. It cancels out on this side. It also cancels out right here because pi divided by pi will just cancel out. And I'm left with 16 is equal to r squared. So remember, if something is raised to the second power, if you're trying to isolate that variable, the inverse is to take the square root. So the square root would be 4, right? So of course you don't have to go through all of this. So if you're given the area and it is like 16 pi or 25 pi, you would just take the square root of that number next to pi. So the square root of 16 is 4. All right, so HK, plugging it in, x plus 8, double negative, plus y plus 11, again that double negative, is equal to 4 squared. 4 squared is 16. And what did you notice here? It's just going to be the same thing, but I want to show you why it's going to be 16, because you may think she's just plugging in 16. She didn't square it or anything, but you take the square root, but then when you plug it back in, it's going to just give you that original 16 there if you're given, or number there if you're given the area. So I've written these two equations in standard form. Okay, we're almost done, I promise. I just have 2 more examples to show you. So with this particular example, we're given a center and a point on a circle. And so I have the distance formula up here, and let me show you why. If we're given the center of the circle, right, and we're given a point on the circle, right, any point on that circle, we need what? We need the radius. So if we go from the center to any point on the circle, it will give us the radius, right? And so in order to find that distance, we use the distance formula, all right? So I'm going to label HK, of course, but with the distance formula, I'm also going to label it X1, Y1, and X2, Y2. I'll use the same color. All right. So first ordered pair, X1, Y1, and X2, Y2. And doesn't matter which one you label, you're going to end up getting the same distance. All right. So I'm just going to plug it in. D is equal to x2 minus x1, so 7 minus 9 squared, plus y2 minus y1, 4 minus 10 squared. And I'm just going to simplify it. 7 minus 9 is 2. 4 minus 10 is negative 6. All right, 2 squared is 4. Negative 6 squared is 36. And so that gives me the square root of 40. So my distance is the square root of 40, not diameter. This is my distance. And so I use the distance formula to find the distance from here to here. So if this were on a coordinate grid, that would be the two ordered pairs. All right, so the radius would be the square root of 40. So I just plug it in. So R is equal to the square root of 40, right? So remember what happens if you already have a radius, not a radius, a radical over your with your radius. If you raise it to the second power, if you can recall from one of my previous examples, it's just going to eliminate that radical. So when I plug it in, it's just going to be 40. All right, so I think I have some room here to write my equation. All right. So HK, plugging that in, it's going to be x minus 9 squared plus y minus 10 squared is equal to, so if we take the square root again, or raise this to the second power, it's going to just get rid of that square root, or that radical, and we'll just be left with 40 because we're raising it to the second power. And that is my equation. So if you're given the center and a point on the circle to find a radius, you would just use the distance formula to find a distance to get your radius. All right, so we finally reached the last example here. And here we're only given two endpoints. We're not given the center or the radius, so we have to find it. So now when you think about it, if you have a circle and you're given two endpoints and you want to find the center, right? So the center would be the midpoint between these two endpoints here. So if we found that midpoint, we could actually find the center. That would be our midpoint. And if we're given two endpoints, to find a midpoint, we would just use the midpoint formula. So that's what I'm going to do to find the center of the circle. All right, so the midpoint, which would be the center of the circle, x1 plus x2. So if I label this x1, y1, x2, y2, adding my x values and dividing by 2. So negative 14 plus negative 10 divided by 2. Y1 plus y2, 1 plus 9 divided by 2. So this would be an ordered pair. Negative 14 plus negative 10, that is negative 24 divided by 2. So that would be negative 12. If I simplify that, 1 plus 9 is 10. 10 divided by 2 is 5. So the midpoint, which is my center, is negative 12, 5. All right, so I found the center, which is my H and my K. So I found one thing. Now I need to find the radius. So if I found the center, so if this is the center, negative 12, 5. In order to find my radius, I could use that center point and an end point to find the distance between these 2 points. So I'm going to use the center and one of my end points, it doesn't matter which one, and I'm going to use the distance formula to find the distance, and that would be my radius. So my center is, of course, negative 12, 5, and one of my points I'm actually going to choose this one here. So distance formula, D equals, and it doesn't matter which or how you label it. So if I'm choosing this one, since I have x1, y1, I'm going to just leave that there. But for my new x2, y2, I'm going to use the center because I have to find the distance from the center to an edge. So I'm using one endpoint, doesn't matter which one, and the center. All right, so x2 minus x1, that would be negative 12 minus negative, so that's going to be plus 14 squared because I have that double negative. Y2 minus y1, so 5 minus 1 squared. Didn't need all that space. And just simplifying it. Negative 12 plus 14 is negative 2. Not negative 2, positive 2. Plus 5 minus 1 is 4. Again, just simplifying it a little more. That's going to be 4. 2 squared is 4. Plus 16. 4 squared is 16. And so my distance is square root of 20. So the distance, which is really the radius, because that's what I'm finding. The length from here to here would be my radius. That would be the square root of 20. So now my radius is the square root of 20. And the center is negative 12, 5. Now I have the information I need to write my formula, to write my equation. All right, so x minus h, so h and k, so minus that double negative, that's going to be plus 12 squared plus y minus 5 squared equals my radius squared. So if I were to raise this to the second power, again, it would just eliminate that square root sign. So that would just be 20. So I have written this equation, standard form, given just 2 endpoints of this circle.